Today we are dealing with classification, like complete classification. Complete classification through like SageMaker, how to do the SageMaker. So first of all, we'll do some basic steps, data science steps, data visualization, data cleaning. Then we will do XGBoost in the local mode, like as we did before. So we'll do XGBoost classification in the local mode. So last time we did XGBoost regression. So this time it is XGBoost classification in local mode using scikit-learn. No SageMaker used. Then we'll do principal component analysis. I think you're all aware with principal component analysis. So we'll do it directly using SageMaker. Then we'll deploy our principal PCA model and do some dimensionality reduction. Like prediction means dimensionality reduction we'll do. Then we will do XGBoost model with the help of XGBoost classifier with the help of SageMaker. Okay. Give me a second. So we'll be using Sage XGBoost classifier. We'll be using SageMaker. And then we'll deploy it, and then we'll make some predictions. And then lastly, we will see we are deploying this XGBoost, and we are making some predictions. And then we are logistic. I think you are all aware with logistic regression. So in SageMaker, it is called linear learner. Linear learner. Logistic regression is called linear learner. So we will in the last we'll do the same results with linear learner, that is logistic regression, and we'll do it using SageMaker. So today we are going to see two algorithms using SageMaker. One is XGBoost classifier and one is linear learner, that is logistic regression. For both we'll be using SageMaker, and XGBoost and personal principal component analysis also we'll see. It's an important dimensionality reduction technique. So that also we'll see using SageMaker. Plus, as a bonus, we will do XGBoost on scikit-learn. Okay, just to compare the accuracy and time taken. Okay, so today we will be doing it on Titanic dataset. So I think every developer who learns the machine learning in the beginning days of machine learning, when they learn, almost everybody works on this problem. So Titanic problem. So these are all variables. These are all whatever I have highlighted here. So they are all nothing but your features in that. And survived is nothing but your Y variable. So Y variable means we have to predict whether that person survived or not. So it is about that famous Titanic accident. And using the remaining attributes, we have to predict whether that person survived we have to predict whether that person survived or not. Okay, so first we have some trained data, and after that we should be able to predict it. Once our model is trained, we should be able to predict whether that person survived or not, and then we'll match it with our ground truth. We'll match it with the ground truth, see how much accurately we predicted. So in this, as I said, survived is your Y variable, the target variable, and it is a binary classification. So all zeros, ones, it is in the form of 0 means not survived, 1 means survived. So it is all between that 0 and 1. After that, passenger ID, of course, it is not useful. Passenger ID has no, it is not having any information value. It is just a number. Then P class is the class in which he was traveling. Name, I think name you can use, but we are not using name in this problem. You can derive some useful variable if you would analyze name and all, but we have not used it. Then sex, age, siblings, parch, ticket, which ticket he had, ticket number he had, like which type of ticket, then fare, cabin, so cabin type, and then embarked. So embarked, there are some places where they are coded here. which place he embarked. So these are all our X variables. So here survived is Y variable, remaining all are X variables. So I'll not spend any time in machine learning part of it because I think we are all aware. So see, passenger ID, ticket, cabin and name. So passenger ID, ticket, cabin and name are dropped. She dropped here. Okay, so see, let us once again, passenger ID. Passenger ID has no information value. Name again, we are thinking there is no information value. Then ticket, so ticket number, like type of ticket, so that's also we are dropping, and cabin. So these all we are dropping. These all fields we are dropping. Maybe that in a further future analysis you should take them into account, but for now we are considering or assuming that they have no information value. So we are dropping them, and then we are filling all the null data with median. All the null values we are filling with median. I think all this you are all aware. So once it is this four fields are dropped and we fill the null values with median. So these are all the fields we are left with. So 1, x1, x2, x3, x4, x5, x6, and x7. So 7 x variables, and survived is nothing but your target variable.
Sir, one question if I can ask now.
Yeah, sure, please.
How will FAIR help in prediction?
FAIR will help. See, you should be a business expert in FAIR. So I think if FAIR is higher, that person is traveling in a different kind of cabin. So if it is an economy cabin, then probably that person will be on lower decks.
Okay.
And if it is a higher fare, then probably he will be on the higher decks. So, and I think they might be given some preference if they are paying higher fare. So they might be given some preference in the lifeboats and all. I'm not sure actually.
Right. Yeah.
So it will make a lot of difference actually. So what fare he is paying or he or she is paying.
Right.
Actually, the position also will make a difference. Like so, actually this Titanic actually it got hit on the bottom side by the iceberg. Bottom side it got hit. So if your cabin is on the lower side, chances of your survival are less. So that's where fare has value. And so like we are taking survived. So like we are getting dummies. So dummies we are getting for P class, sorry, sex and embarked. So sex and embarks are two categorical variables. So for them we are getting dummies. And after getting dummies, we see that all the variables are converted into one-hot encoded. So male, female is converted into sex male and sex female, 0 and 1. And embarked, embarked, there are 3 classes here. So we got 3 columns corresponding to them, one-hot encoding. So 1, 2, 3, 4, 5, we have one-hot encoded columns. And then fair, parch, sibling, and age, and P class. So these are all natural kind of naturally existing numeric variables. That's what we have. So including survive, I have just counted, including survive, we have total 11 variables, including target variable. So if you want to separate, you separate out target variable. So 1 target variable Y and 10 independent variable X variables. So we have X1 to X10, these 10 variables. So based on these all highlighted fields, we have to predict whether that person survived or not. Then as it is customary, like it is mandatory in all the linear learners, like linear regression and logistic regression, that you first scale the data to bring everything into the same scale. See, the data is not on the same scale. Fair scale is different. So it is in tens and hundreds. And age is of course in hundreds. So all data is not on the same scale. And if your data is not on the same scale, then your beta coefficient doesn't make much meaning actually. So to interpret to interpret your beta coefficients properly, it is mandatory for any linear learner that you apply some kind of scalar. So either you apply standard scalar or min-max scalar. So here we have arbitrarily chosen min-max scalar to scale the data. So after scaling, you see now everything is in the scale of 0 to 1. Minimum is 0, maximum is 1. So you can see all the data is in the same scale. So now it is fit for our putting into our algorithm. So before that, we separate X and Y. So X is nothing but your survived is your target variable we have separated. And remaining all variables come under your X category, which are independent variables. Okay. So that's where we separate out. So you see the columns. So these are 10 columns, which are X variables, these 10 columns. Then you know everything, every time that we always do train and test split. So with the train, we train the model, and with test, we always test the accuracy. So we are keeping 0.2 here. So 0.2 means here we are keeping 20% data as test data. And one mistake we are doing here. Can anybody tell here in this line there is one important thing missing? Can anybody tell what is missing? One important thing is missing in this line of code. So I'll tell, you are forgetting, like we always add a random number, random code. Random code is equal to 142, like we add it. And why we add that random code? That whenever we repeat see, one time we got some values. So all these, see, train and test means these X and Y will get split like random records. So they will split in random records, and X train and Y train will be filled up with random records. So we don't have any control what records X train will get and what test will get. So next time when we'll run, X train and X train will be different. X train and X train will become different set, because each time the random number will throw up different X train and X test. So your result will vary actually. So to maintain the uniformity in results, we always specify one thing called random code here after test size. So I don't know exact code, but we specify something like random code equal to 142, 0, whatever you want. But you should keep that number so that your results are repeatable each time. So that's what is missing here. We should always add it. Okay. So anyway, we'll proceed further. So we want to install, now we'll see into XGBoost in local mode. We are not using SageMaker here. We will use simple scikit-learn. So we are installing pip install XGBoost. XGBoost we are installing here with this command. And then we are importing XGBoost classifier. And then we are making an object of XGBoost classifier. So simple. I think you're all aware. And now you had X train and Y train already in the previous steps. In these steps, you had X train and Y train. So that's what we are using here, training data for model fitting. Model fit is nothing but your training. So this particular line is doing model training. So once training is finished, you can do predictions. So your model fit once you fit the model, all the model variables will be stored in this model object, MODL model object. So that model object you can use now to predict. So you are doing prediction here. So predictions are done here on X test. And we always test our accuracy on unseen data. So X test is what is unseen data. So your predictions will look like this, because there are only two classes. One means survived and 0 is non-survived. So I'm not getting into details of confusion matrix, and also it's a classification problem. So it is customary that we plot confusion matrix. So confusion matrix, I'm not getting into detail. Actually, in machine learning class, we have some videos in our channel that you can go through what is confusion matrix, why it is used and all. So once you have Y train and Y predict, so this is Y predict, okay? This is Y train, actual ground truth. Y train is your ground truth. And these are your predicted values. So once you have that, you can plot. So there are how many are wrongly classified? Can you tell me from this confusion matrix? How many are wrongly classified? See, this is 0 here, and this is like how many are wrongly classified?
24.
Like, huh?
24? 18?
Yes, exactly. 18 plus 6 are they are wrongly classified value, and these two red and the cream one, so they are rightly classified values. So if you have this, you can very easily calculate precision, recall, accuracy. So I'm not getting into details, but these are very routine analysis model measuring parameters for classification type of problem. I'm not getting into detail. So we are getting precision, recall, a whopping accuracy we are getting at 96%. Just without any hyperparameter optimization, we are getting a whopping accuracy of 96%. Maybe that if we do some hyperparameter optimization, maybe we can go up to 98 also, who knows. So we have to try that. So we are not getting into that. So this is with the trained data set, we have found out the accuracy 96%. And with the test data set, we have found out accuracy is 79%. So 79% with test data, and with trained data, it is 96%. What does it mean? What does it mean? See, there is a lot of difference, 20% difference here. 96% is the accuracy with trained data, and with test data, it is accuracy is only 79%. What does it mean?
Overfitting.
Yes, it's all 100% overfitting. So your model is overfitting. So you have to tune the hyperparameter. You have to include some hyperparameter in while making object here. XGBoost object when you are making here, you have to include some hyperparameters, and see these are the hyperparameter: learning rate, n estimator, objective. So I am not objective like is okay, it's binary logistic, but these two are hyperparameter, and there are many more for XGBoost: learning rate and n estimator. So we have to tune that, and we have to make sure that training and testing accuracy are in the same range. Like if training accuracy is coming in 96%, accuracy like testing accuracy should be within plus minus 5% of training accuracy. Then you can say but this time it is a clear overfit. So we are not getting into removing overfit because that's a machine learning problem, and we are not right now. We are sitting here to discuss how to use SageMaker for classification problem. But ideally speaking, you should remove this overfitting and make the proper model. Okay. Then you do now principal component. Can anybody tell me what is principal component analysis? Anybody tell me?
Dimensionality detection method by using the attributes correlation.
Yeah, so it's a dimensionality. Suppose you have 3000 features in X1 to X3000. This many you cannot take. So you want first say 20 important parameters. So only 20 important features. So you can reduce the dimensionality and take only first 20 important features, which can contribute to your Y. So see, suppose you have 3000 features. All 3000 will not be meaningful. All 3000 will not contribute to Y, the prediction of Y. So you want just 20 most important features which will contribute to the prediction of Y, which are more important. So you can reduce the dimensionality using PCA, but a disadvantage of PCA is that your features are not interpretable. Like if you are keeping plain features, you can interpret the results. But if you are using PCA like every principal component is a combination of linear combination of your feature. So suppose you are taking first 5 or first 10 principal components, so you cannot interpret them. What does they mean? What does they mean in business? So you cannot interpret the business value of them in PCA. So there's the disadvantage. But you can still greatly reduce the dimensionality. So now PCA will be directly doing, like here PCA you can do using local machine also, but we are directly using SageMaker here. So now we are importing SageMaker class here, Boto3. Boto3 is a general purpose library which allows the use of AWS services like S3 and EC2. And then SageMaker is your global library in AWS Software Development Kit. We import the session. Then we create a session here. So here first we create a session. Then we take a handle on the default bucket. So bucket is nothing but your directory where we stored the data. So we are getting here default bucket handle, prefix. So prefix we are saying PCA. So prefix is nothing but a subdirectory within bucket. So bucket is a directory, and within that you have prefix subdirectory. So the only name is different, but PCA is nothing but a subdirectory, subfolder within bucket. Okay, so bucket is your main folder, and within that you have PCA. We are defining PCA as, then PCA as the subfolder. Then you are getting a role. Role you are getting execution role. So whatever execution role is associated with your AWS user, SageMaker user, which you are executing with. So that role you can get, it can be admin role, or it can be only execution role, or whatever role you have assigned. So you can get default role by using SageMaker.get execution role. So once you got the role, then IO. So IO is nothing but it allows different kind of IO, like text IO, binary IO, and raw IO, input output. So it is that general purpose IO directory, input output library. NumPy, I think you are all aware. And SMAC. So we are importing SMAC also. What is SMAC? So SMAC is a AWS SageMaker common library. So we'll be using like it is also a general purpose library we need to use. So first you need to convert data in NumPy array format to record IO format. So when you are working with SageMaker, if your data is in NumPy array format, you have to convert it into record IO format. And in last session also I had suggested that you Google it out, what is record IO format. So it is one of the standard formats. So you have to know, you should know what is record IO format. It's a special format which I think you should Google out and find out more what is it. But that we need all our data in record IO format. So then this format is required by SageMaker built-in PCA model. Okay, so whatever data you are putting in SageMaker built-in PCA model, that should be in record IO format. So first we are creating a buffer here. So I think this code we have already seen while working with linear regression. So first we have created a buffer here. So IO dot bytes IO will create a buffer. So it's an in-memory byte array, like it's a buffer where it's a buffer, like it's a memory buffer where I'll write my data. Then like DF matrix is a simple object data frame array object I am defining, and X was in a data frame format here. X is a data frame format here, and to NPy means I am converting into array format. So with this line of code, I am converting my data frame X variable, X matrix into X is a data frame, and I am converting into array format. Okay. So two-dimensional array. So now DF matrix is nothing but a dependent variable matrix. It's an array. It's a dependent variable array. Independent variables array x1 to x10, because we have total 11 variables. And if you remove one survived, which is your y variable, so we have total 10 independent variables. So DF is an array of, now it's an array, two-dimensional array of 10 independent variables. Now, what we do, it's a very sparse matrix. A lot of zeros are there. So we are writing it in the form of dense tensor to show the space. We are writing in the form of dense tensor. So what is the class we are using? SMAC. SMAC is specific to your SageMaker. It will not run in your local machine. So SMAC dot write NumPy to dense tensor. So DF matrix is nothing but a NumPy array. So we are writing it, converting it into the form of a dense tensor. So all zeros we are removing, and we are keeping values which are populated and meaningful. So those values only we are keeping, converting a sparse matrix to a dense vector. We are converting, and we are using buffer. So buffer we had created here, this in the first step. So we are using buffer, and that we are writing that array. So all the array, like all the DF matrix, which is in array format, sparse array format, will now be stored in buffer. Buffer in memory, it will come in memory, and in dense tensor format, like much more efficient, memory efficient format. So dense tensor is nothing but memory friendly, memory efficient format. So your DF matrix is containing a lot of zeros, which is not memory efficient. It is not memory friendly. So we are converting it to memory friendly format. So in DUF is our memory buffer where we are writing it. And once we write it, As we do in files, we are seeking our buffer pointer to 0. Like we have to write it, we have to read it, the buffer from the start, right? So we are resetting the pointer to 0, buffer pointer to 0. We don't know where our buffer pointer is right now. So we have to start reading from 0. So we are bringing it to 0. So simple steps. I think we have seen all these steps in linear regression as well. So now we are importing here operating system library, which is standard Java library. Now here key I am defining here one string I am defining as key. So this PCA is nothing but my file name. PCA is my file name. And now I am uploading my all the data. So all the data which was there in this buffer. So this dense tensor I have done this dense tensor, and I had written in this buffer BUF. So now I am writing all that buffer into S3 bucket. So what is S3 bucket? S3 bucket is nothing but your directory in SageMaker or AWS where you store your data. You can store large amount of data in S3 bucket. So it is nothing but your it's your directory, and buffer is nothing but your active memory. So from active memory, now I am writing into hard disk kind of thing. So buffer S3 bucket is something hard disk kind of thing. So from active memory, I am writing into S3 bucket. And why I am writing into S3 bucket? Even if you are using any SageMaker algorithm or any SageMaker algorithm, if you are using built-in algorithm, it is mandatory that your data should be in S3 bucket. So see, now I am taking Boto3 library. So Boto3 library resource. So which resource I want to use? So I want to use S3 bucket resource. And which directory I want to use? So bucket is nothing but our top level directory. Then we are giving a path here. So prefix, we had defined one subdirectory here by the name prefix. Then in that prefix, we are making one more subdirectory called train. And that in that key is your file name. So prefix is nothing but see, bucket is your top level library. Sorry, top level directory. In that you have prefix subdirectory. In that we are making train as one more subdirectory, and key is the file name. And then we are uploading here. See, this is most important method. So upload file object. So file object buffer, BUF. So whatever buffer we had created here, buffer we had created here buffer. So this buffer we had created, right, in the form of dense tensor. So now I am writing it into my S3 bucket. My file name is key. So my file name is key. Key is nothing but PCA. So it will be stored in a file by the name PCA in S3 bucket. So S3 bucket is nothing but kind of hard disk for AWS. Okay. So now my data is in S3 bucket. I have stored it by this particular line of code. I have stored it in my S3 bucket. So it is now ready to be consumed by my algorithm. So what path I stored it? So I have constructed the path here again. And if you print the path, so this is the complete path where my training data means my X train, like X train we are using, right? Complete X, like whatever my dependent array was there, independent variable array was there with 10 columns, because I have 10 features, right? So I have 10 columns in my X array. So all that data is now stored in S3 bucket, and this is the complete path here. Okay, so this, whatever you see, this path is your default bucket. This is your default bucket. This PCA this is your prefix you created. So this is one more subdirectory we created, and PCA is your file name. So this is the complete path where it is stored. So right now we are storing here the data. Our all independent variables are stored here. Now what I'm doing, I'm defining output location. Why I'm defining output location? When my model will be trained, so my trained model will be stored by my trained model artifacts. All the trained model details and artifacts will be stored in this output location. So I'm defining it as bucket and prefix. So location is this. So this is the place, PCA plus output. So this is my default bucket. This is my default bucket. S3 is my kind of my C drive, and this is kind of my default bucket. This is my default bucket. PCA, under that I have a PCA directory. And in this where this is the complete path where my model output will be stored. Now I go ahead and then you know that for running any model in SageMaker, you have to import first the container. So in the previous video, I had explained what is a container. Container is nothing but your complete model code, the complete code of the model, including its environment. So it's like a Docker image. So it's like a Docker image, a complete model code with its environment, all the environment factor, all the environment software, all the environment is and your model is contained within with model and its environment, complete running environment. We copy it as an image. So it's like a Docker image. So with this command, we were importing. So this first get image URI. So this is the procedure we are using to call our image, container image. And this particular thing which I have highlighted here, boto.session.region name will give you region name if your region name is North Virginia, Ohio, or Mumbai, whatever region you are working in. So that region name will be we get from here, region name. And from that region, you are importing PCA container. PCA container, that's what we want. Principal component analysis container. And we are storing it here in a container. So now container. So this container object is nothing but the image, the complete image of PCA model code, algorithm code, model code with its environment. Okay, so complete environment I'm storing here. Then what I'm taking, I'm making now I am real model. I'm starting my model building. So here all the models are called estimator. If you call linear regression also, it is estimator. If you call logistic regression also, it is estimator. And if you call XGBoost also, it is estimator. So all models are called, all algorithms are called estimator. So I'm SageMaker.estimator.estimator I'm using, and I'm passing the parameter. So I want here specific model, right? So I want PCA model here. So I'm passing here PCA specific container. I'm passing role, then instance count, like how many parallel runs should be there. So we are in a free tier. So we can run only one instance one time. So it should be 1 by default. If you make it 2, in 5, it will give error because you are not in you are in a free tier. Then you have to instance type, means this is your hardware on which this is your hardware actually. So this is your hardware MLC4 X large. So there are some free hardware and some paid hardware. So I have chosen this paid hardware to run it faster. So MLC4 X large is a hardware or a machine where your model will run. Output path is just we defined here. Output path we defined earlier, where our model output will be stored, and we have to give our SageMaker session. Okay, so this is how you define you get the basic model object. So PCA is here now basic model object. Now in that you have to set the hyperparameters. It is very different from what we do in scikit-learn. In scikit-learn, while importing PCA, we define all the hyperparameters within the brackets in that method itself. But here we have to separately define. So you have to. It is completely different from your scikit-learn. So now we have to set hyperparameters. So like total feature dimensions of 11 feature dimensions, we have total 11 features, including Y variable. Then you have number of components, so like number of principal components. So I'm not getting into details. So we are here we are capturing six primary principal components. So what are principal components and how many we can choose, 5, 10, 20. So that all depends on your business needs. So right now we have chosen an arbitrary number of 6. So we are taking first 6 principal components. So we are taking first 6 principal components, which are most important to predict Y. Predict our Y variable. So we are taking first 6 ones. Rest all information we are discarding. Okay, so 6 we are setting up. It is arbitrarily chosen. You can take 10, 5, 10, 12, 3, 4, whatever you want. So it depends on your. So if you take more, 10, 20, and all, so number of principal components, you would say 20, 25 if you take instead of 6. So that means you are giving more variable, more information to your more information to your algorithm to predict Y. So your predictions are likely to be more accurate if you take more principal component. Okay, so here we have taken arbitrarily taken only 6. So subtract mean is equal to false, and then algorithm mode, regular algorithm mode we are taking, and here we are supplying in the form of a mini batch size. So when we do scikit-learn, there is no mini batch size for PCA, but here we are to supply data in batch size. So it is a hyperparameter which you can tune. So batch size we have arbitrarily taken 100, or now we have taken it 100. So you can tune it for better result. And automatic hyperparameter tuning is also possible in SageMaker. So in the next class, in the next couple of videos, we'll take it up how to do automatic hyperparameter tuning. But right now, whatever values we have chosen here, except this algorithm mode and subtract mean, all are arbitrarily chosen. Okay. So then we say S3 bucket data. So S3 trained data we had defined here somewhere on the top. So S3 trained data we had defined here. That is nothing but your data where it is nothing but your S3 bucket location where your training data is stored. So now we are giving it is in the form of a dictionary. So train is your key, and your train data is stored in this path. That's where it is stored. So we are providing it in the form of a dictionary, and we are now here. That's where this is the code where your model training is happening. So it will take some time. You have to wait for a while. All the details are thrown, and if you want to study them, I think they are not even a very user-friendly format. So usually it is difficult to read, but it is throwing a lot of information at you. So if you have some time, you can analyze this information, what it is throwing. So it's not very user-friendly format, but still it is throwing a lot of useful information about the model training. Okay, so it took around training for me. It took around 147 seconds, and billable seconds also 147. And I told you in previous video, like there are means and ways to reduce your billable seconds on SageMaker. So right now my training seconds are equal to my billable seconds, but there are ways that I can reduce it by 90%. So it is possible that training seconds will be 147, and it is possible that billable will be only 10. So there are some tricks. So we'll cover it in a later video. So right now it is I will not use them. So it is 100% billable. So now my model training is over. So my model is ready. So I can deploy it using just one line of code. This line of code. So PCA is nothing but my trained model. I'm deploying it .deploy, and then instance 1, and then instance type. Instance type is nothing but your machine on which hardware machine on which it's the equivalent of instance type is the equivalent of your hardware machine where your model will be deployed. So there are different type of things you can choose, and charges are also different. So I have chosen this ML M4 X large. So it is chargeable. So now once your deployment is, it takes some time actually. Deployment takes some time. So when deployment is over, you will get this exclamation mark here. So it will come like this, and at the end exclamation mark will come. Exclamation mark comes means your deployment is over. Now my data, which now I can do predictions. Okay, so why I have deployed? I can do prediction. So prediction means what? Nothing but I'm reducing dimensionality. So I have chosen here n component equal to 6. So what I am doing, total I had 10 components, x1 to x10, independent variable were 10, x1 to x10. So I am reducing them to 6. I'm reducing the dimensionality from 10 to 6. It's not a great reduction, but you can go on and choose 3 also. So you can, if you are reducing from 10 to 3, it's a significant reduction. It depends on your the accuracy you want, the type of business problem you are handling. So prediction I am doing here means I'm using now PCA, whatever PCA model I got, I'm using it to reduce my functionality. So what functionality I'll reduce? Train and test data. Okay. So I have deployed it here, and my deployment, it is called endpoint here. So model deployment endpoint is nothing but PCA reduction. This is the name of my endpoint. I can use it to do the function, feature reduction. Now I can use it for my feature reduction. So first, all my data is in text and CSV format. So I have to use CSV serializer and JSON serializer. So this is my endpoint. So I have to use serializer as CSV serializer and deserializer as JSON deserializer. I think you need to do a bit of even I need to do a bit of more research on what is this serializer and deserializer. So maybe in a later class, sometime we'll take it up. So, but these are the steps which are required because your data is in CSV and text format. So the PCA is reduction, but is PCA underscore reduction is nothing but your deployed model endpoint, which is your deployed model. So you are giving serializer and deserializer here. Now you can do predictions. So predictions you have done dot predict, your endpoint dot predict, and all array you are giving. See here, your np dot array. So it is array you are giving. So first X is in a data frame format. So you are converting it into array format and give it in the form of a batch. So for this complete X, you will be getting your results. So you will be getting your results in this format. See, so you are reducing dimensionality from X or X is actually your array. So it was having 10 columns. Why 10 columns? Because our independent variables are 10. And we are reducing it to 6 using PCA. So now your PCA, whatever results you are getting, so this is nothing but reduced form of X. Okay, so how many? So it will have 6 columns. Okay, so you count here. There are total 6 columns here. These are 6. 1, 2, 3, 4, 5, 6. 6 columns here because you are reducing dimensionality. Originally, X was 10 columns. Now it is reduced to 6 columns because you have reduced dimension, you have used PCA to reduce the dimensionality from 10 to 6. Now, this is in a little bit JSON format. So it is a JSON format, not very readable. So you can use this particular simple line of code, a simple for loop, to unroll this JSON file. And if you unroll that JSON file, you will get prediction in the form of a simple array, simple numpy array. So now it is simple numpy array. So you see there are 6 columns here. You count it. 1, 2, 3, 4, 5, 6. Because we chose to reduce the number of features from total 10 were there, so we chose to reduce to 6. That's what we chose. So that's why there are 6. So this array is having throughout 6 columns. Okay. So these 6 are nothing but your principal components, which you can use for your predicting Y. So this is now these particular predictions. This particular array, whatever array you look here, this array now you can use for prediction of Y. In place of original X, which was 10 features, now you can use this particular array, which is having 6 principal components, like 6 equivalent to 6 features. This you can use for making predictions. So this is your shape of your reduced array. And now never forget this step. Once you have done with PCA, you better delete your endpoint. So otherwise it will incur unnecessary charges. And end of the month, you will be left with a nasty heavy bill, which you may not like to pay. So it is a heavy bill you will be left with. So, but always you can forget everything else, but not this. You have to delete the endpoint. So here, what we have done so far, we have done a lot of analysis, data visualization, missing value imputation, plus splitting into X and Y, and that the X which was in having 10 features. So we have reduced the dimensionality to 6 features. That's what we have done here. So still Y predictions are not done. So this is not a prediction of whether survived or not survived. This is simple, reducing X from 10 features to 6 features. That's what we have done so far. Now predictions, whether survived or not survived, prediction of target variable, survived or not survived, that we have to do with the help of XGBoost model. So next step is your XGBoost model with the help of SageMaker. But in the interest of time, I think I will close it here because already it is close to 1 hour. and next I will complete in next Saturday's lecture. Okay, so we'll take one more class to finish this. So now we are left with XGBoost with SageMaker. XGBoost we have already seen with scikit-learn without SageMaker. So this time we'll do it with SageMaker. So yes, this is XGBoost classifier with SageMaker. And once that is finished, we'll have one more step. We'll deploy it and test it and compare it with scikit-learn, how the results compare. And then we'll do predictions with the help of linear classifier with SageMaker. So linear classifier is nothing but logistic regression. So we are using two algorithms here for the prediction of Y. One is your logistic regression, that is called your linear classifier in SageMaker. So linear classifier and logistic regression are one and the same thing. We'll use it for making predictions. And another that algorithm that we'll use for making prediction is your XGBoost. So XGBoost we will be using SageMaker. So these two things are pending. And right now what we've done in detail. So right now we have finished our principal component analysis. So principal component analysis is what we have covered with the help of SageMaker. And we have successfully finished it. And we are from our variables where originally we had 10 features. So we have reduced the dimensionality from 10 features to 6 principal components. So that's what we have achieved today. And now after that, we'll use that this particular just give me a second. So this particular array, predictions array. So this is nothing but your new X now, because it is having only 6 features, 6 principal components. So this particular array will be used to make the predictions Y. We'll use this particular array to make the predictions of Y. We'll not use original X. We'll use this one with 6 components. So this only this we'll use, okay? So we'll use this to make the predictions of Y, and we'll do that in the next class. So till then, good night.